Hello friends, welcome in a lecture of fluid mechanics subject. Myself Mitesh Patel and I am a assistant professor in a mechanical department at a Dr. Subhas Technical Campus, Junagadh. Today's our lecture topic is a Pitot Tube. So in this lecture we discuss about the Pitot Tube, its application and the equations of Pitot Tube is derived. So let's start the lecture. First, Pitot tube is the most accurate device for velocity measurement. It works on a principle that if the velocity of flow at any point becomes zero, then pressure at this point is increased due to the conversion of kinetic energy into the pressure. Okay, so Pitot tube is work on this principle. The Pitot tube is consist of the glass tube bent at a 90 degree, and the 90 degree one bend is a short length and is open in both hands. It placed in the floor with its bend leg directed upstream so that stagnation point is created immediately as shown in figure. The S is a stagnation point. Okay. The kinetic energy at this point gets converted into the pressure energy, causing the liquid to rise in the vertical limb and to the height equal to the stagnation pressure. So we can get the stagnation pressure from the height of this liquid column. Okay. Now we applying the Bernoulli's equation between the stagnation point and P point as shown in figure. This is a P point and this is a stagnation point S. So here and here apply the Bernoulli's equation at this two section of pipes. So we know that the three energies considered into the Bernoulli's equation: pressure energy, kinetic energy and potential energy Z. Here pipe is horizontal, so potential energy at a section 1 or stagnation point or point P is equal. So PS is equal to ZP. So it's cancelled in this equation. Or we also discuss in just only at a stagnation point S, the velocity is 0. So no kinetic energy. So at a stagnation points only and only the pressure energy. So in right side only pressure energy is there, PS upon specific weight. Now at a section or at a point P, the pressure energy P0 upon specific weight and kinetic energy V square upon 2G, and potential energy is not considered because it's cancelled. Now we know that the P0 upon specific weight is a pressure head at a P point and PS upon specific weight is a pressure head at a stagnation point. So both pressure heads are defined by the H. So P0 upon specific height, so pressure head at a P point is defined by the H0 and pressure head at a stagnation point is defined by the HS. Now we have get the equation from this relation. V is equal to under root 2G HS minus H0 from this relation. Now HS minus H0 is equal to H and H is a dynamic pressure head, and dynamic pressure head, it is defined by difference between the stagnation pressure head and static pressure head. Okay, and this is the equation of velocity of Pitot tube. Okay, so we can measure the velocity through Pitot tube by this equation. Now, in theoretical, this equation is a theoretical equation, but in actual, we know that some losses are there. So, actual velocity value is less than the theoretical value. So, actual equation is that V actual is equal to CV under root 2GH. CV is the coefficient of Pitot tube. Okay. Now, in this equation, H is a dynamic pressure head, and its value is find out if the manometer is used in this case of Pitot tube, then is given by this equation, or find out by this equation the value of H. H is equal to X Sg upon SO minus 1. Now Sg is a heavy liquid of manometer. In most of case or general case, heavy liquid is a mercury, and SO is a flowing fluid into the pipe or Pitot tube. Okay, or light liquid, we can say that, minus 1. Okay, now we discuss about that how this equation is get from the manometer column. Okay, now the U-tube manometer is connected in this way as shown in figure. So left limb of the manometer is mentioned the stagnation pressure, and right limb of the manometer is mentioned the P point pressure. Okay, P1 is a stagnation pressure and P2 is a P point pressure. Okay, now we consider the datum plane as shown in figure and equating the pressure above the datum line at the left side and right side of the limb. So at the left side of the limb, pressure is a stagnation pressure P1 and pressure due to the column height of liquid rho 1 G H1. Now in right side of limb, pressure at a P point and pressure due to the column of light liquid rho 1 G H2 and pressure due to the column of heavy liquid rho H G X. Density rho H is a density of heavy liquid and rho 1 is a density of this flowing liquid. Now we know that we have to find out the dynamic pressure head, so we have to find out the pressure difference P1 minus P2. So arrange in this way the equation. Now we take the common rho 1 G value, so in bracket H2 minus H1 plus rho H G X. Now multiply by the minus in this element. So value of H1 and H2, sorry, sign of the H1 and H2 is changed. So here H1 minus H2. So H1 minus H2 nothing but the defined by the X. So here in bracket, here they put the X instead of bracket. Okay. So P1 minus P2 is equal to minus rho 1 Gx plus rho H Gx. Okay. Now rearrange the equation and Gx is take the common. Okay. Now right side of the equation we multiply and divide by the density of water. Now, ratio of density of heavy liquid to density of water, we know that it is the ratio define the specific gravity of heavy liquid, and similarly density of light liquid upon density of water, this ratio is defined the specific gravity of light liquid. So here write in form of density ratio in form of specific gravity of heavy liquid and specific gravity of light liquid. Now, specific gravity of light liquid SL is take a common from the bracket, so SH upon SL minus 1. Okay. Now, we know that specific gravity of light liquid is equal to density of light liquid upon density of water. So, density of light liquid is equal to specific gravity of light liquid and density of water. So, here density of water into specific gravity of light liquid. So, we can write the density of light liquid here. Okay. Now, G into rho L is moved to the left side upon the P1 minus P2. So, equation becomes shown in slide. Now, we know that this is the pressure difference head and that is mentioned by small h. So, final we get this equation and we find the value of pressure at difference by this equation for a manometer case. Okay. Now, we solve the example of Pitot tube. So, you have idea how to solve the example for a Pitot tube. So, let's start the first problem. A submarine moves horizontally in a sea and has its axis 50 meters below the surface of water. A Pitot tube properly placed just in front of submarine and along its axis is connected to the two limbs of U-tube containing a mercury. Okay, U-tube manometer is used and heavy liquid is a mercury. The difference of mercury level is found to be 170 mm and find the speed of submarine knowing that the specific gravity of mercury is 13.6 and that of seawater is 1.026 with respect to fresh water. Okay, specific gravity of seawater and specific gravity of mercury is given. Value of X, U-tube manometer, heavy liquid difference is a 170 mm. Okay, so it's a value of X. Now we have to find out the velocity of submarine. So we know that the equation of Pitot tube, from that we can find out the velocity. So V is equal to under root 2gh. So we have to find out the value of small h. And we know that the value of h can find out from this equation in the case of manometer. So h is equal to x, sg upon s or minus 1. So sg is the specific gravity of heavy liquid. So it's a mercury. So value is 13.6 and specific gravity of light liquid is water, seawater 1.026. Okay, minus 1. So we get the value of small h, dynamic pressure head, and put into the equation of velocity, and we finally get the value of velocity in meter per second. We also convert into the kilometer per hour. Now solve the second example, Pitot tube. a pitot tube is inserted in a pipe of 300 mm diameter. The static pressure in pipe is 100 mm of mercury vacuum. Okay, the stagnation pressure at the center of pipe recorded by the pitot tube is 0.981 Newton per centimeter square. Calculate the rate of flow of water through pipe if mean velocity of flow is 0.85 times the central velocity, and take a CV is equal to 0.98. Okay, now we write the value of given data. D diameter of pipe is given 300 mm. So we find out the cross section area of pipe diameter. Finally, we have to find out the rate of flow means the discharge Q, and we know that what is the equation of discharge? A V. Here V is the velocity, mean velocity. So we have to find out the mean velocity, and mean velocity depends on the center velocity, and center velocity we find out from the equation of Pitot tube. So first of all, we have to find out the value of small h of dynamic pressure head. So we know that dynamic pressure head is equal to stagnation pressure head minus static pressure head, and which value is given in this data. So stagnation pressure head is 100 mm of mercury. So here pressure head is given is a column of mercury. So we have to find out in column of water. So pressure generated due to the column of mercury is equal to pressure generated due to the column of water. So rho GH is equal to rho GH for mercury, rho GH for water. Now we have to find out the column height of water. So it's a ratio of density of mercury upon density of water, and HM, it's a height of mercury level or mercury column. Divide by 1000 because it's given in mm. So convert into the meter. Mercury height is given in mm. So it's converted to the meter. So now put the value of all things. Density of mercury is a 13.6 and density of water is a 1. And the HM, height of the column of mercury, is a 100 mm. So divide by 1000. So it's converted to the meter. Here the sign is mentioned is negative for a static pressure head because it's mentioned that the vacuum, it's a pressure lower than the atmosphere pressure. So it's defined by the negative sign. Now stagnation pressure is given Newton 0.981 Newton per centimeter square. So it's converted into the Newton per meter square. And now you get the value of small h, that is a 2.36 meter of water, and this value of small h is entered into the velocity equation, and we finally get the center velocity 6.668 meter per second. So from the center velocity we can find out the mean velocity v bar, and that is a 5.6678 meter per second, and from the mean velocity we find out the rate of flow of discharge of water, mean velocity into area of pipe. Area of pipe we can find out from the diameter of pipe, pi by 4 d square, because it's a circular section. So finally we get the discharge 0.4006 meter cube per second. Okay, so I hope friends you understand very well the concept of Pitot tube, application of Pitot tube, and how the example is solved of the Pitot tube. Okay, thank you.